everyone and welcome to my channel. In today's video, we'll try understanding the simple concept around VNet peering, service endpoints, private link and private endpoints. Although these concepts are very simple, still there are people who are always confused in the differences between these. Now let's consider a scenario where there is an organization which has the resources in two different geographies, US East and Southeast Asia. Corresponding to these geographies, we have different VNets and underlying resources within this VNet. All of these resources are infrastructure as a service resources. In this case, we consider VMs having PostgreSDB setup and Kubernetes setup on them. Because of the organizational needs, we want both of these VNets to communicate with each other because the underlying resources need to communicate for a business requirement. Now the organization has a constraint that none of this traffic should go over the public internet and all of these connections should happen within the Azure private ecosystem. The best way to solve this problem is by making use of VNet peering. What we essentially do in this case, we peer a VNet to the VNet which is there in a different region. And once that peering has been done through the Azure console or through the Azure web interface and has been accepted by the other VNet as well, the connection can happen between any resource of a VNet to any resource in another VNet. And all of this communication happens over Azure backbone and hence is private. Although this seems to be a very classic way of solving this problem of intercommunication, often the problem which comes around is overexposure of the resources between the VNets. To explain this further, say there's another resource in future which has been created in VNet B. Since both of these VNets has been peered together, this new resource will also be accessible from the resource which is there in VNet A. Now let's consider another scenario where the organization doesn't want to make use of infrastructure as a service component, rather they want to make use of PaaS components, platform as a service components because of the underlying benefits. Now the requirement is, again, the resource which is a Kubernetes service in VNet A wants to connect to this PaaS component privately without getting exposed through public internet. It is noteworthy that this PaaS component has a public IP associated, so anyone can actually come through the public internet and connect with it. Now what we are trying to do is we are trying to solve this problem that whosoever connects from the VNet A goes privately through to this PaaS component. Now what is the benefit of doing that? The benefit of doing that is that the traffic from VNet A to PaaS component will always go through a private connection and hence no one will be able to see what is being the content of this interaction. So the best way to do this when you don't want the connection to go through the public internet is to make use of something which is a service endpoint. Service endpoint is a capability that you enable within the subnet in the VNet, and once enabled, the connection, and you need to enable it for a particular PaaS service. Once enabled for a PaaS service, all the connections from this VNet, in this case VNet A, and the subnet to the PaaS service will happen over the Azure backbone. And hence all of these connections will be private. Now, the problem still remains with this solution that although the connections are private, there is still a overexposure because in future, say, more DB servers, PaaS components are created. Since a service endpoint has been created in this VNet to connect to Azure Postgres SQL DB PaaS service, it will be able to connect to any of the future DB servers as well. Also, another problem is since there is a public IP associated with this PaaS service, which is a DB service, anyone can still connect through the internet to this PaaS service. To solve both of these problems, let's come to scenario C, where we disable the public IP on this pass service, which is a DB service, and still we want the connection to happen from this um, infrastructure as a service, which is a Kubernetes service hosted in VNet A. For making this happen, what we can make use of is a private endpoint. Once a private endpoint has been created in VNet and enabled for a particular instance of a PaaS service, all the connections happen over the Azure backbone privately. Now, this is what is private endpoint, but the underlying concept or underlying framework through which this communication happens is essentially the private link, which is established between the PaaS component and the subnet. If you'll try breaking the private endpoint further, private endpoint is nothing but a combination of network interface, private IP associated with it, and a DNS resolver which will resolve this private address to reach to the particular PaaS instance. Now note that it does solve the problem with the service endpoints because one private endpoint has been created for a single instance of a PaaS service. So if you create new instances in future of a PaaS service, you'll have to create a separate private endpoint for that. Clearly, this by far is a very safe approach of clearly defining the responsibilities and giving the access to only the needed resources across the VNet. Now let's compare all of these between some of the parameters. For example, on traffic path, if you'll see VNet peering, service endpoints, and private endpoints all communicate through Azure backbone. If we consider the public exposure, VNet peering doesn't have any public exposure to any of the resources within. All the traffic goes from VNet to VNet over the Azure backbone. But in the case of service endpoints, since the PaaS service has a public IP associated with it, there's a possibility of a public access directly to this PaaS service. In the case of private endpoints, there's no public access possible because there's no public IP associated with the PaaS service. Access scope, if you'll see, this was one of the problem. In the case of VNet peering, full VNet to VNet access is enabled. In the case of service endpoints, subnet level access to all the instances of the service is available, which again is a problem. Whereas in the case of private endpoints, resource level access via private IP is only available, and this is the best option that you really want in a secured ecosystem. All in all, from a security standpoint, VNet peering is medium security because you are unnecessarily giving additional privilege. The same reason in the case of service endpoints as well. Whereas in the case of private endpoint, it is highly secure because it is fully isolated in terms of giving privileges to the resources. I hope this would have helped you understand these concepts better. Thanks. Keep watching the future videos as well. See you again.